When we're looking at our JavaScript files, 0 is just a blank document. It's just a starter HTML file. Again, if we are working with an HTML file in our code editors, we can use the code completion that will give us the starting page template. But we don't have any script going on, but this is just to get us thinking about the fact that we need a core HTML that we will be adding our JavaScript to. All of the samples we will look at today, the JavaScript and CSS, are all part of the same HTML file just to keep things a little bit simpler. As your projects grow in complexity, you will generally put all of your script in a separate JS file and your styles in a separate CSS file, and then you will have those in a project directory. But for the learning purposes today, everything will be contained in a single file. Now, to make a script function, it needs to be in our script tags. So if it's an external script.js file, we do not need the script tags. We just have the contents of the script. And we will look at that at a future session. But today, everything will be directly in the document. So the script tag can be placed in a couple of different places in our document. In this particular document, it's in the body. Traditionally, we need to put it in either the head or the body section. When the script is put in the body section, it usually is going to be at the end. And when we look at some other examples, it will become more apparent why that is so critical. In this sample, I could have my script in the head section as well. So if I wanted it up in the head, I could have it up here, and it would still perform and behave exactly the same with no change. Now, this particular script is doing one thing, and it's going to output to the JavaScript console in the web browser and print out a message. Now, using the console is a really common way to track what your program is doing, because JavaScript usually does not fail silently. But when it fails, we don't always know where or why it failed, or we don't know if something's actually working. So we will put messages into the console tracking what is happening in our program so that we know what JavaScript is thinking or what it's doing or not doing. And we log those messages in the console. So it's a kind of an easy way to debug our program. So looking at the script file inside my browser, I have opened up the console. So View, Developer, JavaScript Console. So in the console, if I look at the start file, there's nothing there because it didn't do anything. If I look at file number 1, we can see that it outputs to the console, and it outputs Hello World. So it's doing exactly what I asked it to do here. Moving into file number 2 allows us to talk about variables. Now, when I work with variables in JavaScript, we initiate a variable or instantiate it or tell the program to our web browser to reserve some memory for this particular item with the word var. In some programming languages, we are required to type our variables, meaning we have to tell the computer what kind of variable it is. Is it a number? Is it a letter? Is it a string? Is it an image? Is it a sound? We have to tell it what we want to store in that variable construct. JavaScript has the word var. That's it. It doesn't care what you put in it. And I could put the number 12 in here. And if I look at this file and run this file inside my browser, it prints out the number 12. Now, I can also put quotations around it. I say it's going to be the string represented by the number 12. If I do this, look at it in my web browser, as far as I can tell, nothing has changed. But we can see that something will be changing, because if I were to say it's 12, and if I go 8 plus 12, now if I reload this, we'll see 8 plus 12, okay, that's 20. But if I say 8 in quotation marks plus 12, we will see that it comes up as 812. It's no longer treating that 12 as a number. It treated it as a string, or similar to being letters. So JavaScript is recognizing that even though I didn't put the number 12 inside quotation marks, meaning I want it to treat it like letters, not as numbers, it inferred that because I had a string or a letter first. So it said, oh, well, I'm assuming that means you mean something more like this. So it's making that an inference. And it's nice when it does that and it works out in our favor. But there are times where we will code something incorrectly and ask it to do something, and we're not trying to make an inference, and it makes an inference, and then we don't get the result that we want. So it's important to recognize that that can sometimes be a problem. Through what this is saying is I've set my variable number equal to 8 plus 12, which we saw printed out as 812, because it's treating it as letters, and it's adding those letters, but in this case they're numbers, together. And then I told JavaScript that, well, I want number to now be equal to 6 plus 4. So it goes, okay. Well, you wanted that 812 before, but if you want 6 plus 4, I'm happy to do that for you. So then it adds up 6 plus 4. And then that's what number is now equal to. So a variable, when we use the word var, we're creating that kind of little memory box to store something in. Every time after that we refer to that variable, we can assign a new value to it if we so choose. And we assign a value with a single equal sign. So I say number is equal to, and then whatever I want to put after it. In this case, I said 6 plus 4. So not only can I assign a value to it, I can ask JavaScript to even perform calculations. So it's adding together 6 plus 4, and then assigning that sum, which is 10, to my variable number. When we work with our variables, we are using it as a way to reference an item. And oftentimes we don't know what the value of that item is. We just know that we want to know the reference value. So we just have that part we keep track of. And we really don't even care half the time what the actual number value that was assigned to it, or the string value, or whatever the object is. We just want that reference. So I've created a variable first number and second number, and then a third variable total. And I've set total equal to the sum of those first two numbers. So we can add numbers directly, like what we saw on the previous example. But we can also add variables together when those variables reference other numbers. So now, looking at this, number 3, when I add those, we see it comes up and says, oh, 7. And we can see, okay, 4 plus 3 is 7. Now, if I were to put quotation marks around my first number, so it's now the string number 4, and it will indeed print 43, and I've put quotation marks around this, converting this from a number to a string. and it does not care which number comes first because it's making that inference. Because a string, it can't unconvert that string into a number. It just treats a string as a string, where a number can be accepted as, well, we think you meant a string, so we'll let it go that way. And it's usually fairly flexible on that. Now in number 4, we will see that we can not only add things, but I can multiply, divide, and subtract all of these basic math operations. And there's more math operations that we can work with, but these are the core 4 that we will probably use the most often. So if I log this out right now, it's going to start out and give me a value. So jump back. And we can see that we're now getting a couple of different values popping out. So we can add, multiply, divide, and subtract. So add, multiply, divide, and subtract. And we can see how we are getting each of those math operations computing for us. So we're able to display each one of those values. We can use actual numbers, or we can use variables that are representing numbers that we may or may not know the value to when we are doing our coding. Working with strings, we did it a little bit as I played with the numbers, but as we see, a string doesn't have to be a single letter, but it can be a combination of words. So on number 5, looking at our string variables, we can see it spits out the text. Now when I move over to number 6, you will see that we can combine together strings as we did numbers plus strings previously, but now if I do a string plus a string, I can combine it together. And looking at the results, combining the strings, we see it prints out hungry hippo. Now you may have noticed that there's this little middle section in between, and that was to add a space between the two words. If I did not have that, then when it prints, we would get a single word. The two strings would slam together. So we have to add in a string filled with a single space to create that gap between the two words. It's not going to automatically assume, oh, you have two strings, you put them together, I should put a space between them. Now, there would be algorithms that we could use where we could say we're combining words, put a space between each one. So we would be able to add in a string space between each of the words. So we could append that on the end of each word as you string them together. The last word, don't put a space and put a period. So we could actually write an algorithm that would accomplish that. And at some point this term, we may actually be doing some of that string combinations, because that gives us better grammar when our computer is talking to us. So we'll look at doing some of that. Now another concept within programming is the concept of true and false. So when something is true or false, it's referred to as a Boolean value. And the computer really does enjoy thinking in that context. So our computer likes this idea that we can measure things black and white, 1, 0, on, off, or true, false. When we do that, it makes programming easier. So if you can ask the computer a question where you're only asking or looking for a true-false answer, that will often simplify the programming that you're trying to do. If you're trying to ask for a complex answer, chances are you need to actually distill it down or break it into a series of questions that are all yes, no, or true, false. And if you use that mental approach, it's going to be easier to start to create more complex programs. So looking at number 7, I'll see it prints out true because universe eaten was false. Later on, we change it to true. We print out what is the current value of it, and it prints out as true. So we can change values. We have true, false. Now, going back to our numbers, where we very commonly will use a true, false statement is when we compare something, and we ask with an if statement. So we say if, and then inside parentheses, we're asking, is something true or false? So is the first number equal to the second number? And right now, we can see if they're the same, it'll log out the numbers that are the same. If they're different, it logs out different. And we see the numbers currently are logging out as different. Going back into this, you may have noticed that there were 3 equal signs. And what the 3 equal signs is asking, it's asking the question of, are these things the same? Is first number equal to the second number? And are they the same kind of thing? Now, if I remove one of the equal signs, reload it, okay, the numbers are still different. Oh, I expect that. Now, you'll notice that the computer just told me the numbers are the same. But if I look here, I'll see first number is the number 10. The second number is the string 10. And it just told me they're the same. And I just spent a little bit of time telling you that a number and a string aren't the same. But what's happening is the JavaScript compiler in our browser is analyzing these two terms and saying, well, they have the same value, the same number of characters, and the characters are the same. So technically, they're the same. But if we put it in a third equal sign, we're going to ask, are these the same? And are they of the same type? So do they have the same value and they're the same type of item? So now when I run this, I will find that, oh wait, they are indeed different. General recommended practice when writing conditional statements in JavaScript is to always use the triple equal sign, dumb it down to the double equals if you realize how you wrote your code requires that. But if you err on the side of being extra strict, so when you're doing an equality comparison with the triple equal that says, I want this to be the same value and the same type of entity. And if you do that, chances are you will have less unexpected consequences or errors occur in your code. So err on the side of using triple equals unless you realize how you made your program. It'll be easier just to remove an equal sign and it still mostly works. And you're like, fine, I'll live with that. And that's OK. But if you always start with the triple equal as your go-to, you're going to be in better shape. While we have equal signs to compare things, we can also ask if a value is greater than or less than an additional value. So I can look at is first number greater than second number. You can see the second number is greater, looking at the code. First number is greater. Nope. So let's see, second greater. Second was 12, so 12 is indeed greater. Because first number, we're asking, is first number greater than second number? If so, or because it's true, it would respond with that. And because it's false, it goes with the else statement. Now, the same way that we could compare numbers, we can also compare strings. So if I run this, see it responds with animals are different. If I use two equal signs, the animals are still different. Now, if I make it the same, animals are the same. That all capitals is not the same as lowercase. So if we were to ask you, what is the value? Is a hippo a hippo? Say sure. Okay, all lowercase, or I capitalize the first letter. Sure, it's kind of the same thing. But it's telling me they're different because when it comes to strings, once we put it inside quotation marks, it is case sensitive. Variable names are case sensitive. Strings are case sensitive. Function names are case sensitive. So JavaScript is a very case sensitive language. When we do HTML and CSS, it is not case sensitive. They really don't care. JavaScript is case sensitive. JavaScript is not white space sensitive. So you can add as many extra returns, line spaces, spaces between things, or no spaces between things. JavaScript doesn't care. It's perfectly happy if you have no spaces in any of your code. And if you come across JavaScript files that have been minified, where you'll see the file name as typically filename.min.js, meaning it's been minified, the primary thing they're doing is removing every single white space or line return from the code. Cuts down on file size. It also makes it harder to read as a person. So it kind of obscures your code a little bit, making it theoretically harder for someone just to copy. Good hackers are able to copy it, so then you have to use additional libraries that will actually kind of scramble your code, making it not even directly machine readable. So there are some ways if you're concerned about security. Remembering a web page is an open blanket or open book where the HTML, the CSS, and JavaScript are all readily available to anyone who is now viewing your page. That's okay for most web pages, but when we start looking at web pages as apps or web apps, sometimes we want an app not to be wide open where someone could then just copy it and then repackage it and then sell our work product. So we can use additional tools to try to obscure or scramble our code, making it harder for someone to copy that code. Compound if statement, so we can say if, else if. Theoretically, we don't have to have a final else when we're doing an if and an else if statement. It's considered a good practice because if we have our if statements and our else if statements, if we don't end with an else, on the off chance that our program would reach this point and not have been able to make any one of these things true, then this is the final catch of, well, nothing happened. So it's a good practice to put that in when we are working on our code because it's that final catch. If you don't do it, your program will still run and compile just fine, but it is recommended to do so. Now, a slightly different way of doing compound conditional statement, or an if statement, is called a switch statement. And a switch statement, this program here, number 12, is doing the same as number 11. We had our var cat, then we're asking, is it a horse, a mouse, or a cat? And if not, I don't know. Now we say, okay, in the switch statement, is it a horse, is it a mouse, or is it a cat? If not, I don't know what it is. So it's performing the same operation. What you will notice in a switch statement is there's only one set of curly braces. Now, when we work in our code editor, it's always a good idea, if I click after a curly brace, it will highlight what it believes to be its mate, its paired curly brace. So it underlines this one up here. So it knows I go from here, it's telling me that's the one it's responding to. If I go to my compound statement, if I click here, we can see it joins to that one. If I click on this first one, it's going to the previous one. If I click here, it goes to that one right up there. So use that as a guide when you are debugging your code. So the switch statement is the same as a conditional. And in certain contexts, it's easier to read because we don't have all the curly braces and the if-else ifs cluttering up the screen. So it's a very clean way of looking at the code. Now, sometimes we may want this to be indented, one more click on there, so we see how these cases are part of the switch. So we say switch, and now we're asking the question, is animal equal to horse? Else is animal equal to mouse? Is animal equal to cat? And then it will log it out. Now what happens is if a particular case, in this case cat, would turn out to be true, so it asks horse, nope, it's not a horse. Move on, try the next in the list. Mouse, nope. Cat, hey, it's a cat. Okay, we'll log out it's a cat. And then we have this word break. We haven't looked at break before, but what break does is says, stop going through this list. It says, get out of here, and then continue on. If there's any more code in the program, go with that. If we forget to put the break in inside our switch statement, even if this were true, so if I were to say, I'm going to call this horse right now, and if the break were not there, so we know technically horse is what should fire off and be true. Now if I go to my browser, look at 12, we'll see it printed out, it's a horse, it's a mouse. Because what happened is, all right, well, horse printed out true, and then it's analyzing, oh, now it found a break, and then it could get out of here. Because something has been true, so then it looks for the next opportunity to break out of the switch statement. So the one caveat on using switch statements is if you forget to put your break in, your switch will be broken. So it's important, if I turn off all the breaks, technically it should just say it's a horse. If I run this, we'll see it's a horse, it's a mouse, it's a cat, I don't know what it is. It ran them all because there's no breaks. So it's critical when we are doing a switch statement to have breaks as part of our code. And I see I forgot to change the title on this one. It still says switch statement, and it's not a switch statement. Whoops. So number 13, we're using and. So when we have our conditionals, if we're pairing two things together, we're asking is item 1 true and item 2 true. So when we're looking at this, when both of these situations are true, it'll log this out. If one is true and one is false, it's going to log out the other one. So if I look at 13, we'll see it logs out game over. Because the spell's broken and the witch is dead. Or we can say keep playing. So when doing this, we have and where both situations have to be true, or we only need one of the two situations to be true. We can say if spell's broken, and then we use a double pipe. That's what we call it, the vertical line. You can see the vertical line above the return key on your keyboard. So two of those for or. And when we look at that, I'll see that we only needed one of those to be true. Now if both are false, now we'll see we get to keep playing. So an or statement requires only one of its parts to be true, where an and statement requires everything to be true. When we're working in JavaScript, we're really going to spend a heck of a lot of time creating what are called functions. Functions are little bits of code that have functionality to them. Sometimes those functions will give us something back. Other times they will perform an operation. They will move something, update something. It depends on what we need that function to do. Anytime we reference something in the language where we see parentheses around it, that indicates we are calling a function. So even my line 18 that says console.log and inside parentheses I have the word total, those parentheses are telling me that log is a native function of JavaScript. It's built into the language. So we're telling the console to log out this, and that's a function that's part of the language. And with that, I've created my add function. So I'll pass in my two numbers. I'll call add, and when we look at, OK, here's my function add, and now it will take and create a temporary variable, total, and set it equal to the sum of my two numbers. You see it spits out the value 7. Something else to keep in mind. I have a variable being defined inside this function. That variable is total. Now, outside of that function, if I tell my console to log out total, and we'll see I get an error message. And the error message says total is not defined, and it's telling me what line number. It's really useful to keep up the console when you're coding, because if your program doesn't behave as you expect and you get an error message, it usually tells you what line it failed on. So I can go back into my code, OK, line 20. And it says, OK, total's not defined, but I see I defined total here. But I defined total inside curly braces. And because it was defined inside those curly braces, the scope of that variable, the ability to access that variable, exists only inside those curly braces. The moment I moved beyond the final curly brace, the program stopped remembering that variable. And that is a really critical term. Now, if I were to have something like var total, and now run it, we will see that it's able to keep track of it, because total was defined outside the curly braces, the same way that first and second number were defined outside the curly braces. So we're able to then have access to that value. Just for fun, if I log out my variable first, we can see that it's able to go, OK, that's down there. We'll be able to go find that value. But if we're telling the program, even right here, I'll get it very close. And just so we can tell where it is, so I'm saying log out total, then we call add, then I define total down there. Let's find out what happens. And we'll see that it gives a value of undefined at line 14. Well, line 14, I'm saying log out total. But total came into existence at line 16. So the order of where we define our variables does matter. Where I put the function, not so much. So if I put my function first, we're still getting the problem that total is being defined later. But if you notice, I called add down here when function's up top, but I also called add when function was at the bottom. When I define a function, I can put it anywhere in my code, and JavaScript will find that function. So when you have code, JavaScript will read through and find all of your functions so it knows what where they are. But if you ask to use a variable prior to defining it with the word var, then you will get undefined, meaning it can't find it. So this concept is something that can get a little bit screwy as you work with it. The general practice that most people follow is you define all of your variables at the beginning, and you define your functions either at the end or you define your functions next, and then you actually have your program that's trying to do something. Well, not inside the curlies. Last. So define my vars, define my functions, define program logic. So if you do it in this order, you're generally going to have minimal problems. One of the things that happens is when we are coding, we code organically. We add in the variables we think we need. We start writing the functions we think we need. We start writing the program logic that we think we need. Then we realize we need another function, so we just put it in wherever we're at. And then we realize, oh, we need some other vars, so we start defining those wherever we're at. And then when we try to troubleshoot our code and we're looking for a problem variable and we can't find it because it's in the middle of our program, not at the beginning, that causes issues. So if you can show the discipline to define your vars, then define your functions, then go into your program logic, you're probably going to be happier. But sometimes you will flip-flop functions and logic, and that's okay, provided you define your functions this way. There is an alternative way that we can construct our functions called a function expression, and if we do that, we have to define our functions before we try to use them, or we will get an error, and we will see that in a little bit. When we construct a function, and we call that function, in this case I'm telling the function, I'm calling this function and passing in a parameter, a variable, or content, data, in this case the string hello. Then inside my function, I've now put that as a parameter that that function is expecting, and then I can use that item. But I can also do more with it. I could do even thing to display plus so I can add to it. Oh, sorry. Is equal to thing to display plus. So I have to take the original and add to it. We could use shorthand and use plus equals, which we'll be looking at that a little bit later here and combining things together. So now if I look at this, we will see that it's displaying the thing to display. And I told it display hello, but I appended or I added to hello some more stuff. Our functions can also accept more than one parameter. As we do our projects, we will routinely be creating functions that accept 1, 2, 3, or 4 or more parameters or values so that we can use those inside the function. So in this case, it'll take in these numbers, add them together, spit back out. We should see 7 show up in the console, and we do. The same way that we were able to add previously, subtract, multiply, and divide, we can see we can do the same thing. I created methods or functions, add, subtract, multiply, and divide, and each one is then performing that operation, spitting back that value. So if we look at that, we'll see that indeed it's giving us the values that we would expect based on what is happening here. So we're able to pass in these values. We can create helper functions or helper utilities. So working with the language, there's a core amount of basic functions related to math that have been included in JavaScript. It's not uncommon as you start building more and more programs, like let's say you build some type of user interface or game structure, that you will build utility classes that may extend the math that's inherent in JavaScript so that it can do more. Because you will take the basic math and then you will add more to it so they're easy to call or easy to reference functions instead of the more kind of verbose or difficult way that the language wants you to call upon those actions. So you could take a few different things together, combine it so it's just one call where you just pass in a few values and it spits back the answer that you are looking for. Now, another way to work with it then is to take that a little bit further. The previous file, looking at this, it just logged these values out to the console. Didn't give me anything to work with, so I called add, it put it in the console. But if I want to do something with that number is only living inside the console. I don't have access to it. And this is where we get to work with this really cool feature inside JavaScript where it's going to return a value. So we say return. And when the function returns this value, what's really exciting about this is I can use it for more than just the console. So I could actually return this value and use it to populate the text on my web page. I could use it as a value to control the movements of a game character. So when we return a value, the end result of this, when I run it, it's going to log it out to the console. But if I had a paragraph or some other text field, I could rewrite its HTML with the value that is being returned here. So that would be a use case. And we will be doing some of that in the Mad Libs project, where we will think about wanting to write functions to return something that we can use. We can certainly write without it, but it makes our program much more useful long term. When we have a function returning the value and we want to work with it, so total is now we're calling our add function. Add's going to add the values that we pass into it. It's going to return that, and then we can log it out. So it's what we saw before, but this is now moving us one step closer to being able to use this. So returning a value is going to be an important task that you will need to remember how to use as the term progresses and we get more complex with our projects. The other way of writing a function is as an expression. So we can define a function as an expression. So we say var add is equal to function, first number, second number, console. Now if we look on the previous one, we'll see it's very similar. But in this case, we just say function and then the name of the function. Function expression, we say the name of the function, it's a variable, is equal to function. Now, one of the interesting things about working this way is the order of definition matters. I've defined my function, and it's a variable. It's an object. and then I can use it. It spits back the number 8. If I change the order so that I call add, which this is similar to what we saw before, where I have the program logic and then I have my function after it. So theoretically, this kind of makes sense that, well, it worked before, so it should work now. Now if I try and run it, oh, add is not a function. Excuse me, it says var add is equal to a function, so how dare it tell me it's not a function? But what is happening here is, because I defined my function using a function expression instead of my function as an object, it does not know about it yet. Remember in the earlier project where I said where you define your variables matters. In this case, it does. When we define a function by using just the word function, so if I just say function add, like this, what JavaScript is able to do is it's able to, even though the definition of this happens afterward, it scanned through the whole file and said, oh, look, there's a function there. I'll remember it, so then when you ask for it, I can use it, even if I'm asking for it before it's been defined. So if I were to run this, no problem. It's happy as a clam. The ability to take and understand this function before it's been line ordered in my code is called hoisting. That's the technical term. So it's function hoisting. JavaScript is hoisting this or moving it up to the top so that it knows about it. So it's effectively rewriting my code to look like this. Or we can just say var add is equal to function. So if we define all of our functions as a function expression, JavaScript won't do any hoisting. It also can be further insurance that we're not going to try to use something before it's been properly defined. So there are some stylistic recommendations that people will make an argument that you should define all of your functions as function expressions. So you have your variables, you have your function expressions, and then you have your program logic, because it forces that organization of code. Others say, doesn't matter, it's JavaScript. We should be able to do what we want. That's part of the beauty of the language, is there is not one absolute truth of how to write JavaScript code, which is also part of the problem in writing JavaScript code, is if you look at how to do something, there's 1,000 different ways to do the same thing, and everybody says they're right. With our JavaScript, we can gain access to our page. If we think about, we have content we want to put onto a web page. We use our HTML markup to create our document structure for organizing that content on the page. We use our CSS to control the presentation, how it looks. We use the JavaScript to add to the interactivity and functionality of the web page to make a better experience. To accomplish that goal, we need our JavaScript to gain control of the markup elements on our page. Those elements are part of our document object model, or the DOM. And JavaScript has a couple of different ways to gain access to things on the page. We can access something by its tag name, whether it's a paragraph or a div or a list. We can access something by a class name or an ID, or we can have a single entity query selector, which allows us to just ask for something, and we can put whatever we want in the quotation marks, and that's just a little bit easier. There are some performance issues. Each item has slightly different performance ramifications. Nothing we're doing is such high performance JavaScript that it would be noticeable or that we even need to care at this point. We will explore the other methods to access elements of the DOM through code as the term progresses, but for right now, we will be using query selector. So I've set a variable output equal to document.querySelector. Inside the parentheses, inside quotation marks, I've referenced the ID. Notice I have to use the same notation that I used when I'm referencing an ID through CSS. I use the hashtag or #. And now I am going to set the inner HTML of that element. Notice HTML is in all capital letters. So I have inner and then HTML in all caps, and I'm now going to set that. So first I will comment this line out, and if I go over to my browser, we'll see nothing happens, nothing shows up. If I bring this line back, we will see it is now appended it. If I look at the HTML for my document, I will see in my element inspector, paragraph ID is output, and it says hello world. But if I look at the HTML, there is no text there. So JavaScript has actually written additional content to my page. When we're building interactive content and changing things, that can be a good way to work. We do have to keep in mind is if we are adhering to accessibility guidelines and we are building pages where the content that needs to show up there, if it only shows up through the magic of JavaScript, we may have some issues meeting accessibility guidelines. So if we write our HTML, if we write the contents of the HTML purely through JavaScript, which JavaScript could construct my entire page. I don't even need to query selector. I could actually add a new paragraph to my page, write to its HTML, stick that on there. We'll do that in a later example here shortly. I can do that, but we do have to remember that is not going to be a good approach from an accessibility standpoint. In addition to grabbing control of the DOM, we can also change the CSS directly. Now, as we change the CSS, there's a couple of different ways that we can go about doing it. One is we can assign different classes to things, and that's a pretty common way because here I'm actually assigning direct CSS. So this is about as bad as putting the CSS or the style information directly in my HTML tag, because that's what it's going to do. So if I look at this example, we'll see, okay, hello world, it's been modified. And we'll see paragraph, style, color, red, font size 50. So all of that style information has actually gone directly into my HTML. And we don't want style information in our markup. We want the style information to always be contained in our CSS section. So either in a style tag or in a separate CSS file. So while we can change the style of something through JavaScript, and there will be times for interactive purposes, specifically trying to animate certain things where we may actually be doing this directly because we're changing numbers in JavaScript and then we're just changing that number here. So there will be times where we will do this, but we do have to be cautious with that. We can add to our HTML, so I can use the create element. Creating is a rather expensive proposition as far as kind of CPU usage. Anytime we're making something through JavaScript, we have to be really careful if we're concerned about performance on our page. Again, simple pages and simple programs, it's not going to matter too much, but when you start getting into a project where you have thousands of lines of code and it's more complex, then it does become an issue. If we look at this example, we can see now I have a paragraph right there. And we can see the paragraph has an ID of example. So we can see that we set the attribute ID to example. Now if I look at my page here, I will notice there is no paragraph between my body and closed body. But when I look at the markup inside of the inspector, I will see that that paragraph with that content and that ID have been added to my markup. So JavaScript is quite powerful in this regard. One of the things that we will be using extensively are event listeners. Often we will be using event listeners tied to clicking of elements on our document. In this case, I have a button. So I have a markup button. I gain access to that. Now, it's fairly common that if I'm gaining access to a single element on the page, I don't need to put then any markup saying which button, because there's only one to grab. So query selector will grab the first one of that group of elements. In this case, there's one button, so I don't have to have a class or ID to specifically identify this item. But you'll notice that the tag name is button. My variable name is button. Now, if my tag name was ID is equal to click, or we'll just call it clicker, then I would need to use the pounder hashtag clicker, and I would want to call my variable clicker. So it's quite common that we make sure that the name of our variable corresponds to the name we're using to access something in our code. That way, when I look at that variable, I know what markup element it's talking about. Because I could just as easily call this Fred and call this Fred, and my code would work. But if I read through the code, what's Fred? It has no meaning. It has no inherent tie to the content that I'm accessing. So it would make more sense to represent things together. Now, you may have done some experiments where you used an on-click method that you put directly into your markup when you were trying to add functionality to a button on a web page. So inside, instead of with this, we would say on-click is equal to click handler. We do something like that. We can do that, but at that point, I'm putting additional elements inside my markup. And when we try to work in the separation of layers, my markup is just about the markup. The CSS is just about the presentation. The JavaScript is about that functionality. When we want to keep them separate, by saying onClick is equal to click handler, we're starting to blur that. That's the same as putting in style is equal to and then color and font and all of that. We don't put that in our tags anymore. We don't do on behaviors inside our tags anymore, except in some real kind of special cases that we don't have to worry about in this term. So we want to use add event listeners. So we will grab access to something, then clicker, add event listener. The event we're listening for is click, so that's pressing a mouse down. Then I have my click handler function, which has been defined down here. And it will log out button clicked. I click the button, in console, button clicked. Click again, it's clicking it a bunch of times. So we can see how that script is gaining access to the page, where it's been revised, clicker. Now, we're also able to remove event listeners. sometimes for memory management purposes, when we've added an event listener onto an object, that object is now going to stay in memory until we remove the event listener, because the compiler or browser renderer is waiting to see if anyone will interact with that element that's listening for whatever event is happening. So if I had an animation or a game where I had thousands of objects on screen that were all listening for me to interact with them, and I click and they all disappear, but they're still, I've never removed the event listener, it still is listening even if I can't see them. And that can be taking up CPU cycles, and I can see my performance or frame rate start to drop. So there are times where we need to remove an event listener. So if I click on the button, it's going to call the click handler function. The click handler function will log out button clicked. It's going to remove the event listener, and it's even going to change the style of my button. So if I look at the console, click, and see the button disappeared. Now if I pull up my code, we'll see the button is there, but we can see how its style, the style assigned to it, is display none, which is why it now disappeared from our page. Of course, because I am in Chrome, inside my element inspector, if I right-click, I can choose Edit as HTML, and then I can modify any code or JavaScript. So I can change things to find out, instead of going back into my code editor, making a change, save, go back into my browser, refreshing the page, starting over, I can go just change one little thing right here to find out, is that what I need to update? It doesn't make a permanent change. It allows us to see that temporary change or item. Now I can see here so we have the ability to edit styles and work with styles in our document. There's a lot of flexibility that we have when we're working in Chrome. Take advantage of it. Instead of counting, I'll pull up the console. We see it starts at 0. Go back to the code, we'll see it logged out score. Score was 0, okay. Now if I click me, 1, 2, 3, so we can see how it keeps adding. Every time I click the button, it is adding to my score. Score is equal to score plus 1. Score was defined outside the function, so it now keeps updating itself. We could certainly shorthand this using the plus equal notation. Plus equal notation. So that says score is equal to score plus 1. This is the shorthand notation. Most examples we will work with over the course of the semester will use the shorthand version. Instead of score is equal to score plus 1, it'll be score plus equals 1. That's less to type. Anytime there's less to type, there's reduced opportunity for typos. I view that as a win. So if I refresh and click, we can see it still behaves the same. Now if we change the 1 to a 2, we can see how we can add in. So we don't have to use it just as an increment of 1, but we can now go up by 2s or whatever value we want. Besides the click event, we can listen for the Keydown event. Notice Keydown is all lowercase letters. There's no camel casing going on. I would say 80% of the time I type in Keydown, I automatically camel case it because it's two words strung together, and then I wonder why my code is broken. Such is life. You can call the Keydown handler. Now, when we look at add event listener, it does take 3 parameters. It takes the event inside quotation marks. It takes the function to be called, and then we have this false, which refers to the bubbling of the event. We're not going to get into bubbling of events right now. Maybe towards the later part in the semester when we are finding reasons that we would care about that, we can address the false or true value of that. But it's a required parameter that you have to put it on there. So event, function, false. Anytime you use that event listener, just put that in, you're in good shape. Now my function, I'm going to keep track of the event that just called Keydown handler. So then that will allow me to find out what was the key code of that Keydown event that just happened. And if that number happens to be the number 13, because every key on my keyboard corresponds to a number, it's my ASCII, ASCII key code. That will tell me if I press the Enter key. Now, if we run this, Enter key pressed. If I want to know what key code is being pressed, just comment that out and go console.log. You pressed the event key code key. So as I've put the text here, I'm sandwiching in the key code. I put spaces so that it will stretch it out into an attractive looking sentence. So now, if I refresh the page, if I hit space, 32. So A, B, C, D, E, F, G, H, I, J, K, L. So you may notice that, and I don't remember what I just pressed. So anyway, as you go through the alphabet, you'll see that A starts out at 65 and it goes on up from there. Let's work our way through our 26 letters of the alphabet. My arrow keys, left arrow, up arrow, right arrow, down arrow, 37, 38, 39, and 40. Space is going to be 32. Return is 13. Shift is 16. So as I work through the different keys, if I'm trying to build some sort of application that is using keyboard input, I can now track the numbers that correspond to the keys. If you don't feel like using Google to find out the ASCII key code character chart, which gives you the numbers, you could write a simple program like this which logs out the keys that you are planning to fit into your project. So if you were to build like a classic computer game where you use WASD for movement, so then you have A being left, W being up, D right, and S for down, you see that 65, 87, 68, and 83 correspond to similar things of the 37, 38, 39, 40 of the two kind of movement patterns that we would use on a keyboard-based game. So we near the end with 29 and 30. Looking at 29, we'll see that there is an input, I have a button, and then I have a paragraph with an ID of output, so it's waiting to receive content. Currently, if we look at that paragraph, we will see that it is indeed empty. One of the things that I will need to do is to gain access to my DOM elements. Now, the way that this document is structured, I gained access to the button only. The button has an event listener, which we'll call click handler, and the button has its style changed to pointer so that when I roll over the button, it changes to the hand. This is a computer or pointing device optimization only. On a mobile device or a touch-enabled device where you do not have a mouse, that's irrelevant because there is no hover state. There is no rollover state on a touch device. So that is one point to keep in mind with that. Now I can see that here's some text. If I go to my elements, my body, I have my input, I have my button, and we can see output is there, but there's nothing in it as of yet. So if I put in some text and now click on the button, we will see that that paragraph has now been updated and did receive text. So the JavaScript is now writing the HTML of my output, and it's using the value of my input. That's a key thing, because I can't just say, oh, I want it to be the input. I want it to be whatever the value that was typed into this input field. That's a very important distinction, but it's easy to overlook, because we can say, oh, I used query selector and I grabbed input. But we want to write the HTML with the value of that input. So that is important to keep that in mind, that we're doing it that way. Now, we could modify it and say input is query selector inputs value. So if we do this and refresh the page, click the button, we can see that works as well. So our input, in this case, it's a form field. So it's an input text, and I use placeholder to say enter some text. One thing to keep in mind on that, if we put instructions and the user clicks and types, those instructions disappear. So from a form usability standpoint, having something inside as placeholder text is nice, but we may also want to say something like enter some text. So when we look at it, it's providing that instruction. So when we do that, we have some information by our form field. Relying just on the placeholder is considered bad form, because the moment you type anything, whatever was in that instruction disappears. We have an input field, we have an output field, we have a button. With that, this is the Mad Libs. It's really what's happening with that. Now we can do a few extra things with it. If I bop over to number 30, I'll see that I have a few styles. I have visibility hidden, display none, visibility visible. We could have a display block if we wanted, and we will look more at the differences between using visibility, hidden and visible, versus display, choosing either display block, display none, and things like that. We'll talk more about those in coming sessions. That's not that critical today. But I can see I have some paragraphs here. And I'm going to just modify the paragraphs a little bit here. And just give them some height and width. With my paragraphs having a little bit of size, they'll be easier to see. We can see now I have an input, I have a button, I have 4 paragraphs, output, first, second, third. Now, if I hit the enter key, or if I click on my button, both of those items are going to give me the opportunity to call click handler, which will then update what's on screen. It's nice when you're filling out a form not to have to then, after you're done typing something, to take your hand off the keyboard, grab the mouse, and then click on a button. If you're on a laptop with a trackpad, it's easier because your thumb is right there. It's not so bad. But the general expectation is when we're filling out a form, if we hit the return or enter key, that's the same as hitting the submit button. So looking at the form, or enter button, or whatever we want to call it. So if I type in some text, hello. Now if I click on the button or hit the return key, we can see that it did something. So we can see that hello populated my output. And then first, second, and third, well, something happened there. Let's see. First changed its class name to display none. Second changed its class to display none because the class of DN is display none. So if I look here, there's third. Second has class of DN. First has class of DN. If I refresh the page, we'll see there's no classes on my 4 paragraphs. If I hit return, I'm not checking to see if I entered any text. It's just responding to it. And we can see it added the class and those elements disappeared. Colored just to make it easier to clarify which item is which paragraph. So we can see red, green, blue, and orange for second and third, and my output is in red. So if I put some text here and click on the button or hit the enter key, we will see that first and second had their displays changed to display none. Now if we change it to visibility hidden, so that's FH, so I'm going to change first to FH, change them both to FH just for fun. Now run this. We will see that when we change visibility, documents are still, or elements are still there, they just are invisible. If we say display none, it effectively removes them from my document flow as if they don't exist, and then third bumps up the page. So this is why when we work on our Mad Libs and we have our output panel, we will say display none in the beginning, not visibility hidden. And then when we show the output panel, we make the input panel display none versus using visibility hidden. Because if we change visibility, the item is there, it just can't be seen.